Good morning, good afternoon, good evening, wherever you are in the world. Today, we've got a very exciting episode coming to you from the team at Vanti Analytics. Going to be joined by Nero and Kieran, who are going to be doing a deep dive on everything to look at why AI is so important in your manufacturing and engineering business. To give you a real deep dive on what you can be understanding, how to leverage this, and how to get your business to zero downtime. They're going to be looking at a load of case studies, a load of ideas, a load of frameworks, and be discussing any questions that you have coming through. So it gives me great pleasure to introduce you to Nero and Kieran. But quickly, I just want to do a few aspects to consider while watching this live stream. We are live, so engage with us in real time. Drop your questions in. Kieran and Nero will be picking them out to answer. Make sure you tell us where you're from in the world. We always love to know. And of course, engage and connect with the team at Vanti Analytics to find out more about the awesome work that they're doing. This is going to be a great series. Looking forward to the next hour of insightful discussion. And with that, I'll bring on Kieran and Nero to discuss these next steps with you. Really looking forward to it. And thank you for having me with us today.
Fantastic.
How are we doing?
Yeah, really good.
The stream, but Nero, Kieran, take it away.
Alrighty, look, exciting times. Nero, welcome to the AI Journal and welcome to this podcast. A couple of areas we're going to talk about today, particularly AI and AI in the manufacturing industry and how we're going to help companies. But before we do that, give us a little bit about you. What do you do? What's the origin story of Vanti Analytics? Because did I hear kitchen table to where you are now?
Yes. Well, thank you for having me, first of all. And thanks, Tom, for the intro. Kitchen tables, yes, definitely. Smadal, my partner and I, we go back. We served in the army together, which is a thing that happens here in Israel. And then we worked together at a previous company, Innovis. And when we started this process of ideation and thinking about how we want to launch our startup, then we were working out of her home, her kitchen. I tend to be very liberal with other people's kitchens and food. So I was eating all her food, sitting on the kitchen table, discussing, what we want to do, and then, it was very natural to zoom in on this intersection of the manufacturing and electronics world with AI, since both of us, throughout our entire careers, we were merging data-driven approaches into design and manufacturing aspects of very complex and high-end electronics. Going back and forth, on ideas, it kind of came natural to say, you know what, we've been doing this so long. This is maybe the right place where we are both, very skilled, and we can make this into a product and make this accessible to everyone. And my secret agenda was to eat all her food from her fridge, which I still do from time to time.
And her agenda was to create an office to get you out of her kitchen, to stop you eating that food, no doubt.
Definitely.
So here, if we start a little bit broad at the moment, we hear a lot about organizations and the future of AI, but what does that actually mean? I'm not talking about manufacturing AI just yet, but why is AI so important to companies around the globe these days?
Well, this is just, of course, my opinion, but the way I see it is that, there's this a process going on where a few years ago, we kind of understood that there's power in data. So we began this process of collecting data. We start putting sensors on everything. We start making smart everything. And we can think about these things as maybe agents of data collection. And that's pretty well established at the moment. And so now the next question is to say, what can we do with this data? How can we actually use all of this stuff that we're generating and actually purposefully collecting into some kind of gains for our business? And I think we're at that, inflection point at the moment where, we all know what AI can do for us. We all have resources dedicated to that matter, and we have data. And so when I look at the future, I see more and more applications of the data collected. Also, I'll say that from my point of view, and this is just my opinion, I would say that I see a future, two main things in the future of AI globally. One would be this kind of vertical specific AI. If we can, in the old days, we thought about, a magic black box where we dump in data and we get some kind of a magical outcome. I think more and more we're understanding that AI is, as a tool, as a solution, has to be very well connected to the domain it's trying to, operate in, and the solutions that you need to implement and all the various aspects that you need to handle are very domain specific. So we're going to see, this vertical specific AI, solutions for e-commerce, solutions for insurance, solutions for automotive industries, and so on. And the second is more to do with adoption of AI. People will adopt things they trust and understand, and this is somewhat of a barrier. AI is a statistical tool, and we need to learn how to trust it in terms of my domain and my business needs. And we're going to see more and more efforts into explainable AI and domain-connected AI, and really bridging the gap between like engineers and business professionals and these AI solutions, right? So I would say those two main things.
Why are you seeing that vertical AI trend? And if we focus in just where you and Vanti Analytics focus, which is manufacturing AI, why is that actually happening? Why is it not broad AI? Because I can imagine rather than just manufacturing facilities and IoT devices and whatever, AI could proliferate, hard word, across the length and breadth of a manufacturing company.
Yeah, it's a very good question. I think earlier generations of AI vendors were trying to take on this very widespread approach where they still are creating platforms where you can use your data to create models. But when you move from this POC or exploration phase more into production, into real life, then the characteristics, the dynamics of the problem have to affect the solution, right? As a side project, as a weekend hobby, I built an algo trading bot, just to play around a bit. And I connect to Yahoo Finance. I get the open, close, adjusted close, and the data is very, very set. It's updated at a certain frequency, and that's that. And it's a time series problem, and it's very speculative, and it has macroeconomics and microeconomics. And if I don't address that, my bot really doesn't work. And if I go into the manufacturing aspects, then the data I'm looking at is connected to the manufacturing process, right? If we're looking at a production line, a modern production line, it has thousands of tests, and they are updated, daily. So you add a test and you drop a test. Whereas at Yahoo, it's open price, closed price. It's always the same. If I'm looking at the manufacturing world, then things change over time. Maybe I switched, a vendor for a component, and I'm getting different measurements. Maybe my machine that's taking images for visual inspection loses calibration, or the surrounding settings change, the ambient light, or the layout of the board versus the camera. And all of these changes really, really affect the solution that you have to put in place, because if you don't take this into account, there's not much you can do with the model once the change has happened. And specifically going to the manufacturing world, I would say it's characterized with highly dynamic data. I mean, and coupled with very potentially catastrophic results. I mean, if you go back to Facebook a couple of weeks ago, the world was in crisis mode. No Facebook, no Instagram, no WhatsApp if you're outside of the US, for a good 5 hours. And really, the official statement from Facebook is we had a change in data configuration, meaning the structure of how the information goes from point A to B. It's the same information, the table containing it changed a little bit, and then no one can, no Instagram for 5 hours. And this happens every day in the manufacturing world. So if you don't specifically build your product for that, there's no chance really that you can sustain a model in production. And then there's no real way for scaling it, because one other characteristic of the manufacturing world is that I as a manufacturer, I don't have one problem. I have many, many, many instances of the same problem, right? Maybe I have, 10 different visual inspection stations on my production line. I have multiple production lines spread around multiple factories, multiple products, and so on. So I really want a solution that can be, for all of these different instances. And again, if you don't build your solution to kind of from the core handle it, it doesn't really scale. And you'll find different characteristics per vertical. So I don't see a way around it, to be honest.
So something like manufacturing that is a very specific context, it won't apply outside. But interesting, because sometimes we don't think of Facebook as a manufacturer, but it is a content manufacturer platform of some sort. But Definitely. Give me examples of why do people actually implement AI in manufacturing? Like, where are the use cases that actually provide value? Because all of this costs money and all of this takes time. People could do a lot of things in a manufacturing company. So why do AI in manufacturing?
Well, that's a really, really good question. Really, I would say the applications of AI to manufacturing are very, very wide. I mean, there's a big study from McKinsey from last April, I believe, and they talk about the scale of AI in manufacturing. They state a few interesting things. One is that there's 90% of the impact of AI on manufacturing is untapped at the moment. And they go through a list of various applications. And it can go from predictive maintenance, meaning I want to know when my machine is going to fail ahead of time, or it could be more on the supply chain and predicting inventory issues. And it could be a bit more about what Vanti does, which is predictive quality. And the premise is quite simple. It means I, the manufacturer, would like to know as soon as possible any kind of quality issue in the products I produce, because I can stop it in time. I can prevent it from reaching my end customer. I can either send it to scrap and salvage the parts. I can maybe go to rework. I can maybe make better use of my machine time to produce products I can actually sell. And in this production line environment, more times than not, you'll find that the first time a manufacturer knows if they can sell a product is at the very end. So our premise is simple. Let's predict the quality at an early stage. And we can do this either by saying, you know what, let's look at the data from the testing and the build information from the start and predict a later stage. We can do this, in actual real time on the station itself, looking at images, saying, you know what, this is good, this has a defect. We can actually use the data to say, you know what, you're spending a lot of time testing the quality of the product. We can learn from your history and say, you know what, based on what you're measuring, we can predict the quality. You can save a lot of time and use like this machine that will spit out the quality in real time instead of wasting hours or days going through every single component and checking it.
So just to play that back to you a little bit. So what you're saying is, if in the instance where you were describing quality management, downtime equals lost revenue, downtime equals rubbish product going out, only discovered at the end, and the worst case would be it'd be discovered by the actual customer themselves, which would result in cost. So putting AI in to allow you to, in real time, manage that or predict that allows you to do the maintenance, the management, and the predictive management as well of the production lines. What other uses has AI in manufacturing? You mentioned a couple of other things there, because I can imagine in the front, in the back, in the middle office, in a manufacturing company, there would be tremendous use of AI because they're very data-driven enterprises.
Yeah. So again, my opinion here. I would say that the very first applications would be in the production line itself, meaning let's prevent a lot of this downtime and loss of revenue, using the data we have and assisted by models to predict the quality. But I definitely see how this filters upstream, down, maybe let's upstream, all the way to the R&D cycles, because I'm a designer and I design a product, and later on it gets manufactured and tested, and based on a lot of the accumulated data, I can then go back and update my design. So that's maybe one future application of what you can do with AI in manufacturing.
A moment ago, you mentioned that companies sometimes struggle, though, to get AI models in. And you mentioned multiple factories, multiple production lines, and whatever else. But what have you discovered from a Vanti Analytics point of view? Why do businesses struggle to actually build and implement AI models, number one? And then more importantly, how do customers actually scale AI models across entire enterprises? Because those are two distinctly different things.
Yeah, definitely. So I would say two major issues. One is to do with the question of scaling. So if I'm looking at, I'm an iPhone user, I'm sorry, manufacturing an iPhone, right? You can just imagine the volume, because Apple sells millions of iPhones they carry a wide variety of models, and they have thousands of instances where they would like to predict quality. Some have tabular data, some have time series data, some have images. Sometimes the human effort involved in taking an expert and having them label each image is painstakingly long. And this brings on the question of scale, because a good team of data scientists can explore one use case or one instance and produce a really, really good model, right? But let's say it takes them a month or three, but I have hundreds or thousands. And so it just doesn't fit within a lifetime. So I can have maybe hundreds of data scientists, but that doesn't really happen. Or I could keep going one by one, but a model a month or 3 months, it doesn't really fit in the natural scale of a product life cycle. So really what you want is something that is fast. You want something that has been made into a product, that any engineer or stakeholder or data owner can then say, I have this data, I know the goal, let's meet in the middle and have rapid answers. I want a model, I want to onboard my account in a day, I want a model within 10 minutes, and then go through one or two iterations of trying to improve the model with my domain knowledge, and then say, you know what, this will bring me value. I need to look at the results and say, this will bring me value. This will screen 70% of all my defects, and with very minimal, waste. And I can understand the impact it does, and I want many of these. So that's the one thing we've done. And the second issue is going back to my previous point about downtime in models, right? Because let's say I work very hard. My team of data scientists built a stellar, best-in-class model, and I put it into production, meaning it's now live. It takes in real time new data points, and it spits out the quality estimate. And this will live for a week until the first change in data. Images will go out of focus. A column will be added because an engineer has decided to put in a new test, which is a good policy. Someone will say, you know what, each test takes 1 second and I want to shave off the manufacturing time. I'll move, a lot of these tests to a different location, to a different point in the production line. And then the model really fails. It unfortunately, in our world, model and data are connected in a very, very strong bond, and really it's set in stone. And we know this, Smadar and I, we've handled this over the past few years. So from the onset, from the very first minute, we knew we had to build out specific solutions for it. Really models that don't break. You can shift around the data all you want, and we guarantee that you'll get valuable responses from us, no matter what. And this is kind of like AI meeting the reality of production, because in the POC phase, in the exploration phase, you're not really faced with that, with the drift in the data, as we call it. So that, I would say, from our Vanti point of view, are the two major hurdles of a full adoption of AI.
Yeah, but I'm presuming that's the same in most organizations, because I've ran teams of data scientists, and you end up with two challenges. One is, if you want more models, you add more data scientists, which are hard to get and costly first time around. And I don't think any firm can afford to put 100 AI analysts in unless they're getting multiple value of that. And the second thing is the data inevitably changes. That means half the time they're spending managing and monitoring the models and fixing them, not actually adding new production models into play that allow them to earn more money. So you mentioned the word drift there a moment ago, and building models that allow you to cope with that. Well, what advices would you give the audience that's listening in around those two aspects: exponential growth in expensive analysts and inevitably business change, data changes, and therefore the model has to change, and therefore somehow the model has to be elastic enough to cope? What advice is he giving?
Good question. I think my advice would be, I would start with, acknowledging the problem, or acknowledging the issue. Meaning, really, as a manufacturer, I would need to know that there's a famous framework where someone has laid out all the different aspects of AI, and then building the model is like a 5% block in the middle there, and that holds. And one of the bigger blocks in that framework would be monitoring and really reacting to the problem. My advice would be, step one, acknowledge there is a problem and do something about it. Step two, at the very, very least, have something that can detect these issues. I put a model into production, put something that monitors the model, and then when it starts to see drifts in the data, then it would alert someone. Because really, one aspect of manufacturing is that a model that is misbehaving can actually introduce harm. Imagine, you have a 10-step process, and you're using stations 1, 2, and 3 to predict quality at station 10. But the data has drifted over models over, I don't know, station 2, for example. Now the model, garbage in, garbage out. And if you're looking at these results and you're saying these units are passed, these are failed, but garbage in, garbage out, then what you think is good and then sell on to your end client and customer is actually a failed unit, and you're scrapping a lot of failed units, a lot of good units as failed, because you didn't realize that your model was introducing errors. So at the very, very least, acknowledge the problem and have some kind of drift detector and monitoring service in place. Second advice would be, now that you have something that can alert, is to have some kind of reaction put in place. Okay, and the reaction could be simple. It could be, let's stop using the model for a minute. That's fine. Then call someone. It could be, hey, when we see a problem, let's put in an update. Instead of shutting down, let's put in an update. It could be even more than that. It could be, let's put in active solutions that try to fix the old model once something happened. And it could be something that, on the fly monitors and fixes itself, which is what we are. But I mean, not to plug myself too much.
We'll take the plug, though, because a self-fixing model is something that I think most data science teams and businesses would actually love.
Yeah, I would agree. I think when we talk to potential clients and customers, then this definitely resonates as a major issue. First, the need for predicting quality, and second, just the dynamic nature of their data. I mean, no one will say, you know what, my data is Yahoo Finance. It's set in stone. Nothing ever is going to change. In fact, it goes the other way. It goes, how are you guys going to handle all the changes I have? Because some ML engineer or data science expert on the other side will say, you know what, things are dynamic. They'll bring it up 9 out of 10 times, and then we'll say, you know what, yeah, we know this is the case.
We'll see if we bring in, if you notice, Mike Nash has asked a question there, if you can see that on the screen, and really timely as well, Mike, so thank you. Because we're talking about data quality here. Should we concentrate, as Mike says, on data quality rather than too much in the model? What's your thoughts surrounding the question?
So at the moment, model building is at a very, very high level, meaning you have many vendors, not just us, but like if you go around, you'll have a lot of very capable and good high quality model builders. So I definitely agree. Data quality is extremely important. So you can either have some kind of engineering effort to improve data quality, if you can, or you can maybe focus on automating a lot of the data engineering aspects of the solution that you're buying. Again, going to Vanti, we've seen a lot of manufacturing data in our lifetime. We know how machine logs look. We know how testing data looks. We know how AOI and cross-section X-ray data looks. And we've learned how to pick out a lot of this low-quality data, how to fill in the gaps for a lot of known quality issues, and how to learn shifts in quality over time. And I think I mentioned this before. If we go back to upstream efforts in the R&D side, then in designing the product a bit differently will then create improved quality data being measured towards models. So from a lot of different aspects, I completely agree with the question about data quality.
See, we've been talking about Nero to date, then we've talked about multiple factories, multiple production lines, data that can drift, number of engineers that are potentially required, automation, whatever else. There's a lot here for companies, and particularly any company, but manufacturing companies to wrestle with. How do you go about convincing, CEOs, CTOs, whatever it is inside of those companies, that it's really worthwhile getting into AI manufacturing, not in the first place? And then how do you actually get an enterprise, a manufacturing enterprise, to live this data-driven culture?
Excellent question. So from what we find is that most, if not all, enterprises and even SMBs have already come to the conclusion that machine learning AI solutions hold a lot of potential value, and you'll find that they have a dedicated person, a director of analytics, or maybe VP of analytics, that really is tasked with this effort of introducing, scouting for solutions, introducing solutions, and scaling them out within the organization. You'll find that sometimes these enterprises have, open challenges or have scouting events where they invite people to participate in POC. So there's a lot of, effort, outbound effort from these enterprises to bring in AI solutions. So normally I would say enterprises have this director or VP of analytics in their organization that can kind of, that understands both worlds, the manufacturing business aspects of the enterprise and also the potential value that is held by AI solutions. To date, we haven't really encountered anyone who said, AI, I don't know what that is. I don't really think that's important.
Oh, wow. Wow. And go back and just notice, thanks, Mike, for that great answer, it says Nero. Going back to that a second ago, you were mentioning underlying data. How has Banty dug into the underlying data to get good quality data into the models to allow you to do things? Have you got any examples from your environment and your customers that talk to that? And then we'll Susan's question about dirty data.
Yeah, definitely. I think so the way we go about building models is a bit different than the traditional way we do it. We go from traditionally what you have would be some kind of algorithm or network architecture, and then it's called fitting, because what you do is you fit the data the data to the network, right? It has whatever million different parameters you can train, and you continuously update until you have a good model. We went a different route, more on the neural architecture search, which is a fancy way of saying let the network figure out its own architecture. So we start with data, and then we build out the network to the results. We do that by using a library of building blocks that we created here internally that based on our knowledge of the manufacturing world. It could be physical behaviors that we know for components. It could be other kind of IP-ish type stuff that we've learned along the way. And we kind of mix and match all of those until we get a network that works. And that helps us do a lot of the data engineering, because we know what to look for and we know what to filter out. And we know like how certain things behave, and we know what building block to match it with. So that helps us improve quality along the way. You know what, Kieran, if you have, maybe I can show you a little thing that demonstrates that. Is that okay?
Yeah, that would be really useful, actually. You might need to request share access, but that would be good. And if we could touch on Susan's point when you're doing that around dirty data and how you cope with that as well, that would be fantastic.
Sure. Okay, let me know when you can see my screen here.
Yeah, here we go. It says self-wiring networks.
Yes, self-wiring networks, that's us. So what we see here on the left side is represented by these green circles, are features or data points. It could be a measurement, it could be a test result, it could be an image, it could be many, many things. On the bottom, we have our custom building blocks. Now, it could be very simple, like a triangle. It could be very complicated, like this F3 plus sign shape thing. This is built like an internal library of what we know that works. Some of these function as filters. For example, many times you'll see when a machine will log a value, and then once in a while, instead of a number, it will plug in like a string or whatever. That will break traditional models, but really, we've seen this happen, so we built a component that handles that. Same for missing values. Same for measurements that seem to be, too wacky, or too consistent, or just junk data. Like we log the software version, and it's the same for a million different entries. So we handle that on the custom building block layer there. And then what we see here is that the network will figure out the first layer, meaning how many nodes, which nodes, and how to connect them. It will then figure out the next layer. It could be completely different components and different connectors and different ways of connecting things. You have skip connections. And then the network during the training process will figure out how many of these building blocks, how many layers, and so on. And it kind of builds from features to outputs. So this is the way we build the model. It's a bit different than traditional approaches. It's actually also how we handle a lot of what happens in the drift world. And going to Susan's question, a lot of how we handle this dirty data, because if we put a building block that knows how to spot and clean common effects of dirty data, then we filter that throughout the construction of the network.
Oh wow! And if we're really to test you here now, Nero,
yeah,
have we got anybody? And again, maybe check with Tom in the background. Have we got anybody who submitted data? Because we'll sort of throw this on you. If the model's that good and can cope with dirty data and drift and everything else, it should work every time you run this. Or they do say never work with animals, robots, or live data. But has anybody got a model that they can give us? And if they don't, have you got some data in the background there where you could see this running?
Yeah, I have a data set that we can try this out with. It's real data that has some names cleaned out so that we don't, accidentally share confidential information. We can actually go, yeah.
So show us that model, because I know we did the offer of if anybody wanted to send in some manufacturing data, they could, but I'm not too sure if we have any. So show us that, if you don't mind, a clean set of data, or reasonably cleaned of private information that we're not going to disrupt anybody's confidential business data. So give us a walkthrough and talk to me as if I'm a 5-year-old and I will understand.
Okay, I'll try. So what this is a playground we built internally. The idea here is to take a clean set of data and then a data that has some manual drift introduced. Namely, I removed a few of the columns, right? So I have the model expects an X amount of features and it now receives less than that. Basically, a traditional model will say, hey, I don't know this structure, I'm returning a failure. And we claim that we will actually bring return results. And we'll see that in a minute. So to this end, what I do is I can show you a clean data set. I'll upload a clean data set here. It's tabular data for early fall detection, meaning each row is a different serial number of a product. Each column is a feature, something that is measured. And drifted data here that I prepared today. Removed a few of the columns. In the playground here, we have what is drift. If you already know, then we can skip it. But if not, there's a quick helper here with the 4 common types of drift. But basically, drift is an unexpected, undocumented change in the data structure. It could be sudden, it could be gradual, it could be slow moving, and sometimes it's reoccurring, meaning that it kind of toggles from one state to another. This can happen, if I'm going from one product to another, then I would get the light green result, and then the dark green, and then the light green, and then the dark green. Gradual changes could be when I'm losing calibration, for instance. Things are slightly getting out of focus every time, every minute. I could be having like these sudden changes. I swapped out a component. I had a software update. I had, someone introduced a change in the scheme and dropped a task. And then suddenly all my results look different.
So what is a normal day in a business, you mean?
All 4, to be honest, but we can focus on one of those. Yeah. And then to show really the difference, I did 2 things. One is I went to our application here. I created a new model. It's AI journal. And then demo, selected the early, signed out, naturally. Sign in. AI journal, and then demo, and then I select early fall detection, give it my model, upload my regular data. I see now a snippet of the data, and I can log the KPI, meaning the target I want to produce. For now, I'm just going to use the recommended settings, but you can use the manual settings. You can tell us what you care about more. This is where you put in your domain expertise. but I'll use recommended and hit run. And this is data is now uploading, and the model will be trained just like we saw before in the little GIF there. Training time usually takes, I don't know, 8-10 minutes or so, but I'll spare everyone's 8 or 10 minutes. I already did this before. So I have here what I prepared before. What you see is our build time report. It took 13 minutes. It had pretty good accuracy, some insights, some plain English explanations. But what I'll do, I'll grab from here the model ID.
Just as you're doing that, a model accuracy of 88% is pretty good out of the box, on the basis that I remember doing retention models for insurance companies. We were getting 70% and we were impressed.
As I said, the process of building a model is very, very strong. And we are as good as, if not better, most of the time than most people. But yeah, it's a pretty good accuracy for out of the box. Also a small number of samples, by the way. Actually, good point. I'll grab the model ID here, and I'll plug this into our playground to let the playground know which model it should ping over the API, and I'll set the error handling here to automated, meaning let the model figure it out. I also went and built a model with H2O's AutoML. This is a very, very strong solution. They are very good model builders. I'm using them as a benchmark, really not as a knock, more of saying, hey, this is a really strong solution for model building, but let's see, how it handles drift. I used the same exact data. I ran some training. This is the leaderboard they had. And I'll take the best one, and I'll download the Mojo file, which is the model object, and I'll plug this back into our playground. I will have to set here the error handling to flip a coin. What will happen is we'll try to ping the model, the H2O model, with drifted data, missing columns. It will fail and it will throw back an error. So I put in a flip a coin option that will say just return a coin flip instead of an error, just so that we can benchmark results one against the other. Now, when I hit run, what the playground is going to do is going to take the data, and then take the drifted data, concat it to the regular data, and then sequentially, one by one, try to get predictions from both models, right? Avanti in parallel with H2O, and then we will plot our performance, throughout time. So
I'm nervous for you here, just to make sure this all runs. So you're very brave.
Yeah, me too. So first of all, we can see that Avanti identified that we have like 2 missing columns. The good file had this many rows and 109 features. The drift data had -2 features that I manually removed. We can see some snippets of the data here. But what's interesting is to see performance over time. This is like the number of rows. Now, we're running on the good data now. So both models return really good performance over time. And we can actually see, the ground truth was passed, and Avanti said passed, HO said fell, but most of the time the results are pretty, pretty good. At the 1,165 mark, we're starting to see new drifted data being used to predict. Now, the H2O model is now returning 50% accuracy, meaning it's flipping a coin. It doesn't know what to do with the data that it saw. Whereas the Avanti model, you'll see a drop in performance, but 2 things interestingly happen here. One is that the drop doesn't go to 50%, meaning at its worst, you're still getting some value, better than nothing. So it identified the issue, it quickly introduced a correction, and then still gave you value whilst trying to handle, a better fix. And then the second thing is that you'll see this gradual improvement, meaning the network is now understanding, hey, I have a problem. let's introduce a fix and a better one and a better one and a better one until we've returned now to our baseline performance on the drifted data. Meaning, okay, we dropped a column or two, and they might be significant because we're losing performance here. But a new network is quickly being trained, and we're starting to get better and better results. And really, fairly quickly, you'll get back to your baseline level of performance. So you see, at no point did you have to worry about, is my model broken? Am I introducing more errors than actual value, and so on? And this is where really we take a lot of pride in our solution, because
I have to like it a lot, Nero. As in something changed, and it does every darn day. And the model itself is almost, or literally has retrained itself to get back in a position where it's still reporting so that your downtime is minimized and you can still keep producing.
Yeah. So
you're saying that so matter-of-factly. And I remember running teams for 11 years. Something changed, the model went down, and we then spent 2 or 3 weeks trying to fix it.
Yeah, actually 2-3 weeks sounds pretty quick. We've known of scenarios where it's even longer, and then you have this very long downtime where, you know, everyone inside the organization is now accustomed to a very high level of manufacturing. You know, you're screening out a lot of the early faults. Your yield is very high. Your margins, you know, for your internal margins that you pay for errors in production is very low. And now you've dropped out of that, meaning something is costing a lot of money internally. Yeah. So you see like this hectic scramble to fix the solution, which usually takes a lot of people, more than 2-3 weeks. That's impressive, by the way. And we yeah, definitely. And since we came from this world, we know this is a problem. So we on day one, we knew this is one of the major issues that we had to tackle.
Oh wow. So are you going to show us the next part? And then I have hopefully some more difficult questions to ask you here.
Sure. So maybe I want to show you. It could be a bit too technical. Let me know if you.
I'll try. Treat me like a 5-year-old, and it'll just about work. So go for it.
Okay. So this little GIF. I don't know how to say that. Tries to explain how is it that our network is kind of self-wiring or self-healing on the fly. So it takes the example of dropping a feature. I'll reset in a second. So one of the features here on the top is going to disappear. So step one, the network will identify which of these blocks is now affected by it. It has each block has an internal meter of saying, hey, I'm doing a good job or not. It then will say, you know what, let's rethink the configuration of the layer. Which of these components do I need to remove altogether? Which do I need to swap out? Like on this one, F0 is swapped out with F3, or remove altogether, like F1 here will be removed altogether. And the sequential nature of the way the network builds itself allows it to introduce gradual changes very, very quickly. It's in real time to understand which nodes are affected. It's one tick later, usually orders of time faster than the next data point, to understand what kind of quick fix we want to introduce, and then another quick fix, and then another one, and so on until we regain performance. That's how you saw that gradual buildup of performance. So that was the effort to explain this here. Yeah.
Oh wow, I needed that 10 years ago.
Yeah.
So if I ask a slightly different question, just now, I'll get you to stop sharing for a moment if you don't mind.
Yeah.
In the nicest sense, this is all brilliant. Do you know what I mean? Great analytics, fantastic. You know, manufacturers, you know, they now can have hold of this, but why would they bother? Do you know what I mean? They're not going to do analytics for analytics' sake. Some do. Hence why when the CFO comes knocking, goes, where's the business value? You see the face turning totally white and the panic in the eyes, glaringly coming through. But what's the business value behind actually introducing? And I mean, if you have hard stats, hard numbers, all the better. What's the business value behind introducing AI into manufacturing organizations and processes?
Yeah. So let's maybe think about it this way, right? What is I the manufacturer, I am a manufacturer. What is the cost of discovering quality issues at a later stage? One, I risk the sending out, bad quality units. Second is wasting machine time and material, because these modern manufacturing environments, everything is 24/7, everything is super optimized, because the volume is extremely important. And so really, what is the value of predictive quality is basically saying, let's take the manufactured volume, multiply that by the fail rate, multiply that by my cost of failure, machine time, expert time needed to investigate results, the cost of scrapping material, the cost of not selling good units instead of manufacturing faulty ones. And so if you do that multiplication, you'll see that this cost of failure, or for lack of a better term, can rack up pretty quickly. It's linear in volume, meaning if you produce more, you have more cost of failure. And in today's world, volumes are, huge. It's linear in cost of failure. You spend $1 to understand your failure or to fix it, then more units, more dollars spent, and more experts needed, and more dollars spent. And it's linear in your fail rate, meaning every time you change your product, you introduce a new one, you context switch a machine, I don't know, then your fail rate will increase. And there's a tricky thing about fail rate. It works like compounding interest. I remember going back to my days at my previous company, we were trying to ramp up production of a really, really complicated bit of equipment, right? High-end electronics. And the testing process had 500 unique steps. Now, let's say each step is 95% good, meaning 95% units will pass it, which is very, very high, 98 even, 99% even. If you take that to the 500th power, you'll get that 3% of your units will actually reach the end, because 97 will fail in the way. But you know this at the end. So if you know this, if you can filter this out of the beginning, then your fail rate will drop, and the money you spend investigating these errors and introducing systematic fixes to these errors will go down, and your sellable volume will go up. So if you do that simple multiplication, you'll understand the real value of predicting quality.
Yeah, I think that's a bit I've seen before and we forget as end users. On the basis that I think, Susan, you're right, he has been drawing on the window there to his left shoulder, and I'm wondering if that was the mathematical model that puts the cost in place.
Can you see that?
It's the look the other way, over your other shoulder. The bit here I'm wondering at is, because when units go out, you end up with customers unhappy, reviews being made that are less than wonderful, customer services team, manufacturing team, the investigation of the problem, there's something having to go back through with the cost of returns and whatever else, never mind the rework time, never mind the downtime, whatever else. So that's a bit I think people sometimes struggle with, is to work through every single part of the chain to compound the cost. And therefore, a little bit, if you can get it right at the beginning or prevent it happening in the first place, then all of a sudden those costs disappear. So that I think Martin's saying here, AI roboticists, every use case should start with an ROI calculation. How quick is it to implement a solution, and how quick is it to get that ROI calculation in place, presumably to come up with a rock solid case for manufacturers to implement this or any automation or AI manufacturing solution?
So let's analyze the calculation a bit. The volume is known. the fail rate is known. The cost of failure is known to the manufacturer. The missing component is, okay, out of this fail rate, what can Vanti save? And really, that's pretty, again, we built this to be fast. So you can actually you can go into app.vanti-analytics.com and get a free trial, say Nero sent you, and try it for yourself. Basically, you need a data set, and then you're good to go. Model building time is roughly 10 minutes. I think we saw before 13 minutes. Something that is, within your working day, or if I have half an hour to get this, and that will give you the report, like the one we saw before, will give you, okay, what can I save out of this cost? And we saw 88% accuracy. This is like a typical number. So if I'm thinking all of this volume times cost times my fail rate, this is the potential I can save. Now, out of that, Vanti can save, a very high percentage fairly quickly. Then you can get to your bottom line ROI. What can I save from this model? Like, I don't know, an hour or two, tops. And we'll help with that, of course. And you can try it for yourself on the app.
Or we grab that computation and try and work it out and see if we can do it.
Oh, definitely.
So look, before Tom comes back in and finishes it off, thank you so much, Nero, for today. That's fantastic. It's one of the first talks I've heard on AI in manufacturing, which makes it unique. Never mind what a super solution it looks like you have. It's the first time I've seen models actually coping with changes in real time, because, as I said, I'm used to lower accuracy rates, and when things break, they break. And therefore, half your team is spent actually servicing the models. Never mind, the real value is them constantly iterating and adding new value and expanding models across an organization as well. But if people want to find out a little bit more about you, because you did offer to do demos, ROIs and trials, how do they find out a little bit more about you, and how do they find out a little bit more about Vanti Analytics, and how do they get actually this trial, demo, ROI calculation with you and the team? What would they do and where do they go?
Sure. I'll share my screen quickly because, right, this is it, I believe. Okay, so first thing, you can go to our website. We have case studies published, a new exciting one with a really, really big strategic client that we are excited that, just went up. Some more in-depth, full-fledged content about how to do this and bring along and so on. You can go into app.vanti.com. That's what we saw before, our web application, and create an account. But what I recommend to do is just send me an email. And if you put this at the beginning, I've set up a thing where it pops up to the top of my queue, and I will respond really, really quickly. Just put in, hey, Nilo, I want a free trial, or this. I'd be happy to talk to you about this, and I'll get back to you quickly. Even if you have just questions or you want to follow up, tend to be very responsive. So just put this in. And if you replace Nilo at Vanti with info at Vanti, same applies. That goes into our more business pipelines there, but same applies. You'll get a quick response with trial and expert advice and
questions answered. Well, here, look, we have 60 seconds, and I notice Mike has a quick question. Mike will get this question in as quick as we can, and then Tom, in you come. Can you see Mike's question?
Yeah. What would be the best way to modernize? Well, it's a bit of a tricky answer. I mean, it depends on their data collection ability and if their willingness to be use cloud-based solutions. But the best way is to reach out to a vendor that can take you all the way, help you scope out your data, connect to the databases, advise on what to do, connect everything for you. look for an end-to-end solution.
Someone who can help with the ROI as well, I'm presuming.
Yeah, definitely.
Okay, Mike, hopefully that answers it. But as said, folks, look, Nero's handed over his email address, and Nero at info at you name, you've got all the details there. And if you need to get this as well, shout to myself and Tom, we'll connect you. Tom, do you want to come in and say a couple of end words? But Nero, thank you so much indeed. I appreciate that today tremendously.
Absolutely. I was just going to say the exact same. Thank you, Nero. Some really great insights. And I always said, I remember when we were talking back to when I worked in manufacturing and engineering, these kind of solutions are really what can help companies thrive and go forward and continue success. So really good, comprehensive understanding. And I also want to thank you, Kieran, for moderating a great panel and getting the points across. Nero, I'm loving the kind of outlook with writing on the wall and the topics we discussed. So it was a brilliant session. And of course, thank you to everyone that's joined us, and looking forward to sharing this, because the journey with Vanti Analytics isn't over. So to get this out, we've got one person here who's asking if there's any way to replay this and share it with teammates. So this is all recorded, and we're aware a lot of people that wanted to be with us, and we've had emails coming in that they can't attend. We'll be sharing this with you. We'll be pushing this out through our networks. The Vanti team, Natalie, Smadar, and Nero, and the great team behind them, we're pushing this further. And really, really great insights to help you with your business go along. So for us, we'll be pushing this out more. We'll be putting all the links and call to actions that you mentioned, Nero, how to get in touch, the email to use, what methods to get your data tested. And yeah, really looking forward to the next one, and looking forward to continued success of Vanti, Nero.
Thank you very much for having me. It was a really interesting conversation. Again.
Yeah, looking forward to the next one. Kieran, thank you, sir. Nero, thank you again. And again to the audience, real pleasure.